Hi, welcome to the second of this series on DBA712, which deals with analysis of association. And here we're looking at, so previously we talked about tests of differences, things being bigger or smaller or significantly different. Now we're actually going to look at whether two things are associated. Okay. Sorry about that. Just making sure. Okay, so next slide. Let's go to the next slide. Okay, whoa, let's move myself out of the way. Okay, so the basics are shown here. And sales volume is often used to predict measures of association. And in marketing, we can have, we might be interested in what we call whether things like advertising or dollar sales associated with advertising expenditure. So the convention is often dependent variables are called Y variables, Y, and X are the independent variables. Okay, so in your assignment, you're being asked to predict, I think from memory, intention to purchase movies online, and you have a number of independent variables which you need to consider. Here are some, here's a nice summary, and I'll just move myself out of the way a bit here, for measures of association. So if we're dealing with interval or ratio measures, so interval scales like in your assignment, attitude scales, we can use what's often called the correlation coefficient, or we can run what's called a regression analysis. And the sample question, remember as I said in the last lecture, the question we're asking is really important here. Are dollar sales associated with Are dollar sales associated with advertising dollar sales? Ordinal, chi-squared, Spearman rank, or a Kendall's cow correlation is the rank preference for shopping centres associated with a Likert scale ranking of convenience or location. So is your preference for one above the other? Is that related to things like your income or even perhaps your gender? Nominal measures are shown here. And here we're saying, which is often just the chi-square test, and these other ones here are related to the chi-squared, is sex associated with brand awareness or gender associated with brand awareness. So are more women aware of shoe brands than men? Now, one of the earlier, or what we call, if you've got a lot of independent variables, and one way of assessing whether there's a relationship between a number of range of independent variables and one dependent variable. Or sometimes you're interested in relationships between a number of independent variables and dependent variables. It's what we call the correlation coefficient. Now, it's a coefficient, and it ranges from +1, which means there is a 1-to-1 correlation. So the more I increase sales, the more I spend on advertising. If I spend $1 on advertising, I get a $1 increase in sales. Negative is the reverse. If I exercise 30 minutes, I lose a kilogram of weight a week. And that's a negative correlation. So +1 for positive, negative, and of course if you've got a very small number, there's really no correlation at all. Now, you obviously don't need to worry about this because we have a wonderful invention called computers which calculate this, but this is really just, I guess I'll put this up here just to explain what on earth this correlation coefficient is. And what you see is it's a measure of covariance, the variance of X times the variance of Y, which is that term there, and how much these two things covary or multiply together. So how much the difference, the sum of the difference between X and the mean and Y and the other mean, remember that's the dependent variable, times the covariance of both these measures down here. And so when you put these two together, the square root of that gives you the correlation coefficient. Now, a really useful way before you run off and run your stats program is to actually plot relationships. And so here we have the Y variable here, which is our dependent variable. That's normally in the vertical, and X is the horizontal along here. This is often called a scatter diagram or a dot plot in SPSS, and you can see here this is what a low positive correlation looks like. It looks like when we go up, the Y values get bigger, but we've got a number of lines we can draw. Here's a high correlation, and you notice the variance or variability around a line that I might draw through there is somewhat. And this is a perfect correlation. That's what you look like. Never seen one of those. When you get no correlation, you just basically get a cloud that looks like this. This is a moderate negative correlation. So you can see as X increases, right, along that way, Y gets smaller. And this is a perfectly negative correlation. So this often helps you understanding relationships between variables. Okay, as I said, you've got to get the right kind of question. So whether the average number of hours in manufacturing industries is related to unemployment. So this is a negative correlation. So when the numbers of hours are high, unemployment is low. In other words, we're at full employment. Okay. Now, a lot of people, and you will hear this on the news, talk about correlation. There's a link between drinking coffee and cancer, or there's a link between this. And here are some correlations, so there's evidence, but it doesn't mean that something caused something. It simply means two measures are moving either with each other or they are moving opposed to each other. There may be a third measure in there, or it may be even accidental. For example, no matter how correlated the rooster's crow is to the rising sun, the rooster does not cause the sun to rise. So that's the direction of the correlation. It doesn't tell you the direction. It just says that two things are associated. Teachers' sales, this is from US, and liquor consumptions covariate because of the influence of a third variable, such as growth in national income. So in various counties in America where there is more income, teachers get higher salaries, therefore, right, liquor sales go up. Bottled water is linked to healthier babies. And again, you can see there's an income effect there as well, and a socioeconomic effect. Student grades and the size of wardrobes. So the idea here is that the bigger the wardrobe you have, then the bigger your grade. And of course, this is relating to wealth and privilege. The more wealthy and privileged you are, other things equal, the more highly educated you are. So you might have spuriously related or due to a third variable. Now, you probably can't see this terribly well, but this is an example of some cancer rates plotted against the amount of fat in a diet. Now, remember when I said I drew a line like this is a positive correlation. So it looks like the more fat you consume in your diet, the higher the risk of rates of cancer. Right? Okay, so you can see that. That's the death rate in cancer per 100,000, and that's the amount of fat per capita intake. So all these people up the top here, the answer is stop eating too much fat, otherwise you'll get cancer. Alright? Now, the problem, just getting back to this, is, as we'll see, is there may be other factors which have explained this association. Wealth, privileges, lifestyle, and so on, which are related to cancer. Okay? Not just fat. The coefficient of determination is a measure of squaring the correlation coefficient, and this is really just saying how much something influences the other variable. So if you want to know what the variance of how much dollars explains sales, if we square that, and let's say it's 0.8, it would be 0.64, or 64% often is used, which is a coefficient determination, or what we call the R squared, which we'll deal with later. Sorry, I'm just going backwards and forwards here. Okay, here's some examples of correlation, of what we often call a correlation matrix, and this comes from a study which has looked at a number of measures such as performance, job satisfaction, and so on. So you can see here, in terms of satisfaction, you can see it's related to esteem, outer directness, less to verbal intelligence, territory, and to workload. Okay, of course. If we look at job satisfaction, we can see it's related to not related to workload, related somewhat to self-esteem, related to less tension, and to somewhat having clear ambiguity. These figures down here just show the correlation coefficients are significantly different from zero. As you'd expect, a really small one, like this one here, between outer directiveness and satisfaction is not significant, whereas this one here, which is 0.05, which is B on this one, is significant, And this one here, which is, I think, A on this table here, is what we might call at a 1% or even less than 1% level. So we tend to look for significant correlations. And of course, the minus plus sign tells you the direction of the association. So what it's saying here is that role ambiguity reduces, the more you have, you're unsure what you're here for, reduces satisfaction. Okay? Oh, sorry, performance. Performance is satisfaction here. And job satisfaction, you can see, is also related to role ambiguity there. Now, what do you do if you've got ranks? Well, you can use what we call the rank correlation coefficient, whether the association between sex and rank order and brands of microwave meals, you can do that. Though not commonly used, but sometimes can be used as well. So again, it's important to remember that this table here, all these measures were what we call interval or ratio measures. Now, regression analysis, which I think I'll ask you to do assignment, is often a useful approach. It's used a lot in economics, and it's looking at, and I guess, finance as well, and it's used to weather information, but allows us to build a predictive model based on previous modelling or previous data we have in front of it. Now, the bivariate regression, which is the most simple, is looking at the relationship between two variables, x and y, and it's saying that relationship is based on two constants which need to be estimated, what we call the intercept of the line. So usually this is what's called linear regression, so we assume the relationship's linear, and a sort of slope that fits the data, which we call the beta coefficient. And that's really what we're saying here. Okay, A and B are the two constants. And when we do multiple regression, we just add more of these beta coefficients along here. Now, the y-intercept is the segment of the line, the point at which it intercepts the x-axis. I'll talk about that, right? And the slope is the inclination of the regression of the line compared to the baseline or the mean. Right. Here's an example of some of these things. So what we've done is we've plotted some points, and you can see we've got two measures. Let's say, for example, that this is, along here is dollar sales, and this is advertising expenditure. And you can see that we might want to put a predictive line through. There's my line, and then you draw a line in. So which is the better measure? Well, of course, you probably say, oh, it's the one closest to the points. And you'd probably be right. So it talks about, when we talk about regression, we talk about the line that minimizes the difference between these points and the predicted line there. Okay? So obviously, if all the points were on this line, it would be a perfect regression. If none of the points are on this line, there's no relationship. Okay? But we need to work out, or have some way of working out, which of these two estimates are the more superior. Okay? So the slope on the line is really what we're saying here. So this is the change in x, right, which is the beta, which corresponds to a line. This is why it's often called least squares regression, the least squared difference along here. Why do we square it? So it's not negative. And that's the change in y. So it's this value which predicts the change. The little hat on here means the predicted y values, which are all these dots on this line. So it's not always, or very rarely, 100%. Okay? And that's the change in x. So if you want to work out what the explained regression is, there's the total deviation, all the points there, and we add all those up. There's the deviation explained by the regression, which is the mean score along here and how much we've explained by the regression. And this bit up here is what we call the deviation or residual. You will have heard this phrase, residual, not explained by this line along here. Okay? Explained by the regression. So the idea is to maximize the amount we can explain, and to minimize that which we can't explain. And of course, you might add more independent variables in to explain more. You might think about the regression model. Also, there are things you do statistically. So no straight line can completely represent every dot. And there'll be discrepancy most of the time between the actual scores and the predicted score. Okay. And we use the criteria of trying to make the least amount of total error in the prediction of Y of the sales value from dollar sales in this round. Okay, so here's some more terms, and it's important that you just have an understanding of what they call. This is often called a hat. The actual value is Y whatever. The residual is the difference of the actual value less the predicted value, so the residual will be 0 if they're the same. N is number of observations, I is the number of that observation. Okay, so by regression, the intercept then is the difference between the mean and the mean, the beta times the mean of x. Okay, and that's simply what the regression coefficient looks like, which is really just calculating the slope of the line. Okay, and here are some other measures that are commonly used with that approach, which I won't go into too much. Now, how do you know if you've got a good line? How do you know if the regression's any good? Well, as I probably hinted, you've really got to compare whether you've explained more on the regression than is unexplained. That is, the line is closer to those points than what is further away from those points. And this corresponds to an F-test, which we talked about before. And so what we do firstly is to look at an overall test of the regression of the explained versus the explained to see if this regression is significant. And then we run some other tests on the beta coefficients down here to see if they are significantly different from 0. So a very high beta coefficient or slope on the line, which means it's closer to the points that it's predicting. So a perfectly beta of 1 would mean that the line is perfectly correlated. Okay. Right. Whoops, sorry about that. Okay, so just move myself around here. Sorry, I've just gone a bit random here. Right, so in this measure, the test of statistical significance here, whoops, okay. What I might do is just switch to that, whoops, okay, switch to that, okay. So in this measure here, okay, so the procedure to determine whether there's more variability explained. Okay, here's an analysis of variance of sales on building permits. And as you can see here, obviously the more building permits we get, the more sales that are occurred. So building permits was the X variable, and housing sales or dwelling sales are there. And so the sum of squares of these two measures here, so that divided by that, gives you this score here, and you can see that result is highly significant. So the regression, that's a pretty good model for regression. What's highly significant? Anything where there is a highly unlikely that it occurred by chance. We also get what's called a coefficient determination, our old friend there, which is the correlation coefficient squared that we talked about earlier. Here, that y is explained by x, and of course it ranges from 0 to 1. So here's an example here of a regression analysis which looks at how much a student would spend reading and their overall grade performance, okay, which is the dependent variable. So SPSS does this in quite a nice way. The R squared here, right, which is this one here, shows that it's 0.73 or 0.74, which means it's 74% of the variation of your grades explained by how much you read. The regression coefficient here, or the regression table here, just shows that result to be highly significant, unlikely that it occurred by chance. And you can see the beta coefficient here, there's a little t-test done whether that's 0, and you can see here that the reading time, though, that the beta coefficient standard is 0.86, which is quite high, and if of course we square it, we would get this number up here, and therefore we can say that reading time is a highly significant predictor of your grades, in this case, in the sample. Now, what happens if you want to look at association between two nominal variables? Well, you can do that, but the issue then is that you can't use a regression anymore. The most simplest one is often what's done. It's cross-tabulation or joint frequencies. So you might run a cross-tabulation of income and, say, occupations, or postcodes and occupations. Do doctors all live in one area or not? And related to that is what's called a chi-squared test, which is used to test the significance of the cross-tabulation. Okay, so here's an example here. And as you can see in this example, the proportion of males who are aware and unaware are shown here of a manufacturer's brand. And you can see 50 men, 10 women, 15 men were aware, unaware 25. So it looks like there may be some association. So the cross-tabulation, as we talked about earlier, is the observed less the expected squared over the expected frequencies for each one. We sum all that up and for each cell, and we get our chi-squared value here. Alright, so if the chi-squared value is higher than the critical value, so we'll look that up in a table, or luckily in SPSS it will tell us that brain awareness is not independent of gender. Now, of course, there are practical issues again. There may be a high statistically significant association between variables, but it may not be meaningful. So again, associations have been found, as you saw earlier, between the amount of fat in countries and whether there are high death rates in cancer. But what we know, of course, is that's really a wealth effect, and that more wealthier, more developed countries who can afford to eat more fat, therefore have, they may not be exercising as much, there may be more people living in cities and not, being as mobile, therefore cancer rates go up. So you can get a statistically significant association, but you've got to make sense of it. If you can't make sense of it, it could be accidental, or there could be a third measure. So don't just simply rely on tests to tell you if there's an association. It has to be managerially useful, right? So if there is an association between advertising and sales, well, what kind of advertising? Do we just spend more? It might be more useful to look at whether it's online advertising or whether it's particular types of advertising that predict sales. Manager might want to know that rather than just spending more money. And of course, getting back to the last question about whether advertising affects sales, what we do know, of course, that many companies set their advertising budgets as a percentage of sales of what they can afford. So when companies are doing well, they spend more money on advertising. So does that mean the advertising affects the sales? Or maybe the sales is affecting your advertising budget. Again, just to keep in mind that there are various measures of association that you might want to consider, and really it does depend upon the level of measurement. If we've got interval and ratio, the common approaches are what we call correlation and regression. If we're dealing with ordinal, it's either a rank correlation or a chi-squared test. So level of measurement, you understand that. Just remember that ordered is ordered categories, but they're not equal, like education, income categories. Nominal is categorical variables like gender, colour of my jumper, where you live, postcode, and so on. Okay, intervals tend to be attitude scales, and ratio are things that have a zero, like height, weight, and so on. A final word about regression, which is shown on this. I won't read all this out, but basically this is showing you that if you follow regression models, you're really dealing with the past can change, and you can make the future can change, rather than the past, and you can make some very humorous examples. And this is a very famous example about regression from Mark Twain. So I'll just leave you with those thoughts. Well, thanks for listening. I hope this has been useful for you in your assignment.